Find the 4 second-order partial derivatives for the function f of xy is equal to y to the 5th sine of 2x. So in order to find the 4 second-order partial derivatives, we need to first find the 2 first-order partial derivatives. So that's our first job. Find the first-order partials. And because our function has 2 independent variables, we know that there are 2 first-order partial derivatives. So the first thing is to find the partial derivative of this function with respect to x. So let's keep in mind that we are differentiating with respect to x here. So we are treating y like a constant. So if it helps, we can even think, well, y is a constant. So we have this scalar multiple, y to the 5th, multiplied by the derivative with respect to x of sine of 2x. And so this leaves us with the first order partial derivative of the function with respect to x being equal to 2y to the 5th cosine of 2x. So there is our first order partial derivative. Now we need to go ahead and find the second first order partial derivative of the function with respect to y. Now, as always, it is crucial to keep in mind what variable we're differentiating with respect to. So here we are differentiating with respect to y. So we're treating x like a constant. So let's pull our scalar multiple, that constant to the front, sine of 2x. And now we want to differentiate with respect to y. So we are differentiating y to the 5th with respect to y, which leaves us with the partial derivative of the function with respect to y being equal to 5y to the 4th multiplied by sine of 2x. So this is our beautiful final answer for the partial derivative of the function with respect to x. So now that we have these first order partial derivatives, we are officially ready to go ahead and find the second order, those 4 second order partial derivatives. And we know that there's going to be 4 second order partial derivatives because each first order partial derivative can have 2 second order partial derivatives. So here we go. Let's find the second order partial derivative f sub xx. So just like with first order partial derivatives, it's essential to keep in mind what are we differentiating with respect to. So here we're differentiating with respect to x. So we are treating y like a constant. So here we are differentiating with respect to x our first order partial derivative with respect to x, which was 2y to the 5th cosine of 2x. So again, we're differentiating with respect to x here, so y is a constant. So this is, we have our scalar multiple, 2y to the 5th, multiplied by the derivative of cosine of 2x, which leaves us with minus 2 sine of 2x. And so we are left here with a beautiful final answer. The second order partial derivative f sub xx is equal to negative 4 y to the 5th sine of 2x. And so we have one more with this first order partial derivative. We now want to find the second order partial derivative f sub x y. So again, it is essential here to keep in mind, what are we differentiating with respect to? Well, here we are differentiating with respect to y. So we have d dy. We are taking the partial derivative with respect to y of the first order partial derivative with respect to x, which is 2y to the 5th cosine of 2x. So in this case, 2 cosine of 2x is our scalar multiple. And we are differentiating y to the 5th with respect to y. So that will be multiplied by 5y to the 4th. And this leaves us with our beautiful final answer. The second order partial derivative f sub xy is equal to 10y to the 4th multiplied by cosine of 2x. So we have exhausted the second order partial derivatives for f sub x, and we now need to move on to the first order partial derivative f sub y. So next, we want to find the second order partial derivative f sub y x. And as always, it is essential to keep in mind, what are we differentiating with respect to? So here we're differentiating with respect to x, so we're going to treat y like a constant. So we have d dx of the first order partial derivative f sub y, which is 5y to the 4th multiplied by sine of 2x. So in this case, our scalar multiple is going to be 5y to the 4th, and we are differentiating sine of 2x with respect to x. So that leaves us with 2 cosine of 2x for a beautiful final answer of the second order partial derivative f sub yx being equal to 10y to the 4th multiplied by cosine of 2x. And we're delighted and excited because we see that it matches the other mixed order partial derivative. Woohoo! So we can make a love note here to ourselves that these two partial derivatives are equivalent and we're heading in a great direction. Hooray! So one more to go. We need to find the second order partial derivative f sub yy. And as always, it is essential to keep in mind, what are you differentiating with respect to? So here we are differentiating with respect to y, so we're going to treat x like a constant. So we have the d dy of the first order partial derivative of the function with respect to y, which was 5y to the 4th sine of 2x. So since we're differentiating with respect to y, 5 sine of 2x is our scalar multiple, and we are differentiating y to the 4th with respect to y, which differentiates to 4y cubed. And our beautiful final answer for the second order partial derivative f sub yy is equal to 20y cubed multiplied by sine of 2x. And so there you have it. These are the 4 second order partial derivatives for our given function.